Well, good afternoon. This is Chemistry A, Unit 4. Our first day talking about nomenclature and formula stoichiometry. A little bit of this is going to be a review over the next couple of note guides, but that's all right. We're going to start talking about naming ionic compounds. So let's get started. Now, as you recall, a binary compound is composed of two elements and can either be ionic or molecular. Remember, if they are molecular, that is a covalent bond, so don't forget that. All right. If you know the formula for a binary ionic compound, then we can name it. And we did discuss this in the last chapter a little bit when we were talking about bonding. But we always start with the cation. The cation comes first. And keep in mind what a cation is. A cation is an atom that has undergone a transfer of its electron. Therefore, it has lost an electron. Therefore, it becomes positive. After you have listed the cation, you then go ahead and you list the anion. Don't forget what an anion is. An anion is an atom that has gained an electron or two, and therefore it has become negatively charged. So we name the cation by placing the, we name the compound by putting the cation first, followed by the anion. So if you take a look at our drawing here, we have two cesium metals and one oxygen nonmetal. The cesium is the cation because it is a metal. Metals are the cations, and the anion is oxygen. Now in this case, we need two cesiums to balance out the oxygen. Okay. So when we name the anion, remember we remove the ending of the element and we add IDE. Example, sulfur would become sulfide. In our example here, we have cesium and oxygen, and it would become cesium oxide. Now remember, the 2 is therefore because cesium had to bring along a friend to help balance out the oxygen. Okay, so the cation goes first, followed by the anion, and this is an ionic compound. Okay. Now sometimes, don't forget we talked a little bit about this too, sometimes metal ions form more than one ion. Let's take a look at copper, for example, copper in oxygen. Recall that copper commonly forms two cations, Cu positive and Cu2 positive. The names of these ions are copper 1 and copper 2. How can you tell which of these cations forms the compound CuO? Well, the formula indicates that the copper cation and the oxide anion combine in a 1-to-1 ratio. The oxide ion always has a negative charge, so the charge of the copper cation must be 2 positive in order to balance it. So the compound, CuO, must be copper 2 oxide, and the formula would be CuO. All right, if it was Cu2O, then copper would be copper 1 oxide, because just like cesium in the previous page, it would have to bring along a friend. Now remember, the Roman numerals tell you what the charge of that metal is. In this case, the charge of the copper is 2 positive. Oxygen was 2 negative, therefore the two charges balance out in a 1-to-1 ratio. Now if you know the name of a binary ionic compound, you can also write its formula. You write the symbol of the cation and then the anion. Add whatever subscripts are needed to balance. The positive charge of the cation must balance the negative charge of the anion, so the net charge, that should say charge, is 0. And our example would be potassium chloride. So let's take a look at potassium chloride. We have potassium, which is a group 1A element, so we will say that it is a 1 positive. And we have chlorine, which is a nonmetal, and it is a 1 negative. Now in this case, because it's a 1 positive and 1 negative, it is already in a 1-to-1 ratio. So our formula would be KCl. However, let's say, for example, we have another example here, and let's say that it is, let's go with magnesium and fluorine. So now we're going to change this to magnesium writing. Magnesium fluoride. Magnesium is a group 2A element, so it has A2 positive. Fluorine is a group 7A element, so it is a 1 negative. Now, what we can do here to determine this formula, once we know the charges of those, is do what I call crisscross applesauce. You take this, and you put it here, and you take this, and you put it there. That gives you your formula. So our formula is MgF2. Now, let's make sure that's correct. We know that magnesium has 2 valence electrons, and fluorine has 7 valence electrons. Okay, magnesium wants to gives it over there. That makes this one 1 negative. Fluorine is happy, but we have an issue. Magnesium, again, is not. So this is where you got to bring along a friend. So we draw out our friend here. Magnesium gives that other one there. 2 positive, 1 negative, and there we go. Magnesium fluoride. Magnesium fluoride. Okay? All right, now I'd like you to read page 263, take a look at conceptual problem 9.2, read it and understand it, and then I want you to do practice problem 10 on the back of your note guide, and we'll check it and see how you do tomorrow morning.